While we see an expression in the form like square root x plus y times square root z, it is really weird to see a square root is under a square root. And this is our biggest hint to simplify this kind of expression. To think about this kind of problem, we need to think about the relationship between the square root and the square. Since square root is an inverse function for the square, when we undo a square root, undo a square, or expanding a perfect square, we somehow will receive or might receive some square root. For example, let us see this one. Here, bracket a minus b squared equals c. We undo the square root, undo the square. We receive a equal b plus minus square root c. And this process is exactly the same we do for the famous quadratic formula. And eventually we receive a square root. We receive a root in the form of x equal a plus minus square root b. Simultaneously, for the formula a plus b squared equal a squared plus 2ab plus b squared, if a instead being an integer or instead being a rational number, we write in something like a square root b plus c square root d square. Eventually, we'll receive something like a squared b plus c squared d plus 2ac square root b times d, which here produce a square root. And seeing this, connecting back to our problem, square root x plus y times square root z, we want to write this in something. We say we want the final answer is a, and a, our first thing we want to do is remove the big square roots. So we move this into the right side, we get a square. And now we see x plus y square root z equals something a squared, something square. And by comparison, we can see here is corresponding to x, and 2ac is corresponding to y, and bd is corresponding to z, which is exactly the form we are looking for. So we can do some algebra to find the value of a, b, c, d. Then we can simplify to this format and cancel the square root with the square, and left us with a final simplified expression. Based on this, we can do some problem. Square root 5 plus square root 24. First, we observe. Because we want to get something perfect square, we need something in the form 2ab, because a squared plus b squared plus 2ab. Okay, so square root 24, which is equal to 2 times square root 6. And square root 6 should equal to a times b. But not only that, a squared plus b squared should equal the constant 5. There are two choices. One is 1 and 6. The other is 2 and 3. Both satisfy 1 times 6 times the product of these two is 6. But the only choice that match the add them together will produce a sum that is equal to 5 is 2 and 3. So we can easily see it is equal to square root 2 plus square root 3 square. Square root and square cancel out. We get a final answer. Square root 2 plus square root 3. You can verify if you want. This square will be equal to this without the square root. This without square root. Okay, here's another one. This one is interesting. We can see there's two similar structure, that is square root y plus x times square root z. But rather than writing in the format as two perfect square, we say entire thing as big S. We square it to try to find a way to cancel out these two big square root, and we'll see what will happen. First, we get 4 minus square root 10 plus 2 square root 5 bracket plus 2 square roots bracket 4 minus square root 10 plus 2 square root 5 bracket 4 plus 10 no wait, my bad, 10 plus 2 square root 5 bracket plus 4 plus 10 plus 2 square root 5. These two cancel out and left with 8 plus 2 square root bracket 4 minus square root, here is square root 10 plus 2 times square root 5 bracket 4 plus square root 10 plus 2 square root 5. Okay. We can see by our experience this section and this section are similar. The only difference is the sign change. We can connect with this with the formula a squared minus b squared equal a plus b times a minus b. So we get 8 plus 2 square root 4 squared minus bracket 10 plus 2 square root 5 bracket. Now what we do? We see a familiar structure, 4 squared minus 10 plus 2 square root 5. By simplified, we get 6 minus 2 square root 5. Under square root. Okay. For this one, we do the same thing as before. Based on the perfect square, we want something that sum of its square is 6, but 2ab is equal to 2 square root 5. A times b should be equal to square root of 5, since 2 is cancelled out. The only choice for us is 1 times 5. So we get square root 5 minus 1. Meanwhile, when we see the square root of 5 plus square root of 1 square, we get 6. So it's correct. So yeah, so here we simplify to square root 5 minus 1, and here we get 8 minus 2 times square root 5 minus 1. We simplified, we get 6 plus wait a moment. No. Here I did a mistake. Here's not plus minus, it's plus. Okay. 6 plus 2 square root of 5. And since it's really similar to this one, we know it should also be square root of 5 and 1. By some adjustment, we obtain this one is equal to square root of 5 plus 1 square. But since the beginning, we'll see the entire expression as s, and we squared. So s squared is equal to this. By square root on both sides, the square is cancelled out with square root. So our final answer, s, is equal to square root 5, plus 1. Here is plus. Okay. Then it's our final question. Find square root 5 minus 12i. Our previous method should still work, even though this involves imaginary number. So we do it as usual. We first observe and assume it should be somehow in the form a plus bi square. We expanded a square plus 2ab plus 2abi minus b squared. And this should be equal to 5 minus 12i. Okay. Then 2ab it should equal to 12, and a squared plus b minus b squared, it should be equal to 5. By some simple algebra, we know a and b should equal to should be minus 3, should be 3 and 2. Because 12 over 2 equals 6, 2 times 3 is 6, and 3 squared, 9 minus 4, which is 5. So we get our answer, which is 3 minus 2i, where a 2 times 3 minus 3 or whatever, either way, we get 6. 6 times minus 6 times 2, we get 12. And then 9, 3 square minus 4 square, minus 4, we get 5, which match this one. So our final solution is 3 minus 2i. Okay, that's it. Thank you for listening, and if you like it, please subscribe.